Hello and welcome to the Algebra 1C uh, Unit 6 notes. This is our first day, which is learning some of the exponent rules, but we're going to start out with some exponent basics. So the first thing we need to know is what is this? So we would read this as 2 to the third or 2 to the third power, right? And we have a couple of important vocabulary words that we need to know. First, we need to know that the 2 is called the base. Okay, and the 3, so the big number is the base, and the 3, the little number, is the exponent, right? You guys have heard the word exponent before, but base might be a new one. You're going to hear me say that a lot here. The other thing we need to know is, what does that mean? So if we have 2 to the third power, that means we're multiplying our base, this 2, times itself 3 times. That's the exponent. So this really means 2 times 2 times 2. So it's not 2 times 3, it's 2 times 2 times 2, which would give us 2 times 2 is 4, times 2 is 8. Okay? This also works with variables. If we have something like x to the fourth, that really means x times x times x times x times x. All right, so it's x multiplied by itself 4 times. The exponent is how many times we're multiplying. Okay. Another thing that we want to talk about is the difference between parentheses. So if I have something like 4x to the third, that means 4 times x times x times x. 4 times x to the third. That's the 3 x's. However, if the 4x is in parentheses like this example, 4x to the third power means 4x times 4x times 4x. So we have really 4 to the third power and x to the third power, right? So it's really the combination there. So everything in the parentheses would be affected if it's in parentheses. If it's not in parentheses, it's just the last thing that's being affected by that exponent. So now we're going to get into our first rule, which is the product rule. Product, as you know, means multiplying. So we're going to be multiplying our bases. So when we are multiplying like bases, we're going to keep the base the same. We're going to add the exponents, and we're going to see why in our first example. So if I said 5 to the second times 5 to the fifth, what that really means is 5 to the second is 5 times 5, and 5 to the fifth really means 5 times 5 times 5 times 5 times 5, right? And I'm not going to plug that in my calculator because it's going to be a huge number. What we want to do is just simplify this using exponents, right? So if I have 1, 2, 3, 4, 5, 6, 7 fives, we're going to write that as 5 to the 7th power. Okay, but what's a quick way to get from here to here? Well, if I had 5 to the second and 5 to the fifth, we end up with 5 to the 7th, right? So we're adding these exponents. So let's do some practice here. And remember, the base will stay the same, right? It's always 5 to the second, 5 to the fifth. Our answer is 5 to the 7th. So when I do our first practice problem, 4 to the third times 4 to the fifth, the 4 is going to be the base. 3 plus 5 is 8. All right. For number 2, 3 to the third times 3. Well, if I already have 3 to the third, that means 3 times 3 times 3. Okay, but now we have another 3. So we want to think of this as 3 to the first power. So that's actually going to be 3 to the 3 plus 1, or 3 to the fourth power. Don't forget that this counts, okay? Even if it doesn't have an exponent, it really just means the exponent is 1. In our next example, we have 5x squared times x to the third. So think of that like 5 times x squared times x to the third, right? So the 5 is just its own number. It's hanging out. It's not doing anything. What we're going to do is we're going to combine the like bases, right? So 5 is a separate base. X, we have several of them, right? So 5 is going to stay 5, but x squared times x to the third becomes x to the fifth. Right? In our next example, we're going to have a couple of different bases here, right? So now we're going to go one base at a time. So we're going to look at our x's. We have x to the fourth times x to the third. So we combine those to get x to the 7th. And then we're going to look at our y's. So we're looking at each variable independently. So our y, we have y to the 5th, and here's that just regular y, right? So if we already have 5 y's, and then we have one more, that's going to become y to the 6th. Picture that y as an exponent of 1. All right, and finally, we're going to kind of put all of this together. So we're going to go to the this last example here, right, which says, hint, multiply coefficients together before you work with your exponents. So we're going to do our coefficients first. So in this case, we have a 5 and a 2, right, but they're being multiplied. So we know that 5 times 2 is 10. And then we're going to go to our next variable, or our first variable. So x to the 3rd times x. So again, we have 3 x's and then one more, because that's really x to the 1st power. So this is going to be x to the 4th, and then y to the 2nd times y to the 4th. So if I have 2 and 4, then I have a total of 6. So that's it. 10 x to the 4th, y to the 6th. Let's move on to our next rule. Okay, the next one is our quotient rule, and we know that quotient means it has something to do with division. So our basic rule says, when dividing like bases, keep the base the same and subtract the exponents. It says to always subtract starting with the larger exponent, and we're going to see 2 examples here. One where the larger exponent is in the top, the numerator, and one where it's in the bottom or denominator, okay? So here's our first example. We have x to the 5th divided by x squared. X to the 5th is x times x times x times x times x. X squared is x times x. So what I know here, right, is that anytime I have a number divided by itself, it's really equal to 1. So I could take the pair of x's on the top and the bottom, I can kind of cross them out, put a 1 through them. So I'm going to be able to cross out 2 x's because I had 2 on the bottom, leaving me with these 3 x's on the top of that fraction. So x times x times x, we write that with exponents as x to the 3rd, and that is our answer. In our second example, we have a larger exponent in the denominator, okay? So this one's a little bit different. We set it up the same way. X to the 4th is x times x times x times x. X to the 6th is 6 of them all written out. I'm not going to read them, okay? But now we can go ahead and cancel 1, 2, 3, 4 x's. So I have these 2 x's left over, but pay attention to where they are. They're in the bottom of this fraction. Okay, so I have something over x times x. Well, what are all these things that we crossed out? Those were really 1s because x divided by itself is 1. Any number divided by itself is 1. So that's why we have the 1 on top. It's just a placeholder. And then we write x times x as an exponent, so 1 over x squared. So you see we had more x's in the bottom, so we really did 6 minus 4, right? But it's in the bottom of our fraction. For this last example, it was 5 minus 3, but it was in the top of that fraction, and we don't have to write the denominator when it's 1. We do have to write the numerator when it's 1. Otherwise, it would just be blank. We need something there to show us it's a fraction. Okay. The next thing we're going to talk about is coefficients, right? Coefficients can still be divided. They're divided the same way. So just like when we had coefficients in product rule, we'd still multiply them together. So here we're still going to divide them like normal. So this example, 8x to the 7th over 2x to the 4th, I think of this in 2 pieces. So I think of 8 over 2 and my x's, x to the 7th over x to the 4th. So 8 divided by 2 is 4, right? And then x to the 7th divided by x to the 4th, we subtract and get x to the 3rd. So my answer is just 4x to the 3rd. All right, let's do a couple practice problems here. So again, we're just going to go one variable at a time for these. So for x to the 5th over x, remember that's really x to the 1st. So I'm going to subtract top to bottom. So let me erase that. I'm going to subtract x to the 5 minus 1, right? We have to get rid of 1. So it's going to be x to the 4th. For this next one, I'm going to split this up into 2 pieces, okay? I'm going to think of my x's as one problem. And I'm going to think of my y's as the second problem. So for my x's, I'm going to subtract, but I have more x's on the bottom. So I'm going to actually subtract 9 minus 4. So I'm going to do x to the 5th, right? So those x's are gone. I have x to the 5th on the bottom of this fraction. For the y's, I have 5 on the top, 2 on the bottom. So I'm going to subtract 2 from the top, and that's going to become y to the 3rd. So when I rewrite my answer, all right, I'm going to put y to the 3rd on the top of that fraction, x to the 5th on the bottom of that fraction, right? So 9 minus 4 on the bottom, 5 minus 2 on the top. So you can have a variable on the top, a variable on the bottom. It doesn't matter. For this next one, I'm again going to split this up into two pieces, the 5 over 15 and x squared over x to the 4th. Whoops. Here we go. So I know that 5 over 15 is a fraction that can get simplified. Remember, we're not subtracting here. This is regular division or a fraction that I just need to simplify. So 5 over 15 have a common factor of 5. So I'm going to factor out that 5. That's going to become a 1. And this is going to become 3, right? If this was just a regular fraction, we would write 1/3. For the x's, we're going to subtract 4 minus 2, right? And then so these are going to disappear. So my final answer here, what do I have on the top? If I look at everything I have on the top, it was all canceled, so it's all just equal to 1. So we have to put that 1 on the top of that fraction. And then on the bottom of the fraction, I have 3. And then x to the 4 minus 2, which is x squared. So those are all on the bottom of that fraction. All right, I'll do some more examples. If you think you know what you're doing, you can skip ahead to the next section. So this one I'm just going to separate out. I'm going to say I have nothing over the 7, right? So it's really like a 1 over 7. Have x squared over x to the 4th. And then I have y to the 4th. So you see how I kind of left some space here? I'm just putting my like terms, my like bases together. So I can't do anything with that 7. I can't do anything with the y, right? They don't have any common bases or any other numbers in case of the 7, right? All I can do is this x. I can subtract 2 there, right? So I can do 4 minus 2, get rid of the top, and then rewrite my answer. So my answer here, if I just write down everything that I have going, it won't let me change color. There we go. So on the top of this fraction, we have y to the 4th. And on the bottom of this fraction, I have 7x squared. Done. All right, same thing. I'm going to kind of split this one up. So I'm going to put 24 over 8 x squared over x to the 4th. Oh, we've seen that one a lot now. Y to the 5th over y to the 8th. And now we're going to do our quotient rule. So the first thing is 24 divided by 8. Regular division, right? 8 goes into 24 3 times. So I'm going to replace with this 3 and a 1. Although we might not need that 1 if there's something, well, we only need to write that. We don't need to write the 1 in the denominator at all, right? It's either there's no denominator or we're going to have something else there. So let's see. We've got x's. We got 2 on the top, 4 on the bottom, so I'm going to subtract bottom to top, cross that one off. Same thing with my y's, right? I've got 8 on the bottom, 5 on the top, so I'm going to subtract bottom to top, cross that off. Last step is just a rewrite. So on the top of this fraction, look what I have, just a 3. On the bottom of this fraction, I have a 1, which I can ignore, and then I have x to the 2nd and y to the 3rd. Okay. One more problem. And again, I'm just going to write this out. I'm going to write this underneath here, but I'm going to write 6 over the 8 x squared over x squared. Feel free to leave yourself a little space here. There's nothing wrong with that. And y to the 5th over y to the 5th. So the first thing I'm going to do is look at these coefficients. 6 over 8 is a regular fraction, so I'm just going to simplify that. They're both divisible by 2, right? So if I divide by 2, this is going to become a 3, and this is going to become a 4. So it just becomes 3/4 simplified fraction. The next thing we usually do is we look at which one has the bigger exponent. But we have x squared and x squared. They're the same, right? So these are actually just going to both cancel out. It's just like an x over an x. They're all going to cancel. Same thing with y to the 5th over y to the 5th. If I have 5 on the top, 5 on the bottom, they're all going to cancel. So our very last step is just write what you have left over. Well, on the top of this fraction, all I have is a 3. And on the bottom of this fraction, all I have is a 4. And we're done. Let's move on to the next rule. Okay, our last rule is called the power rule, and it's when we have a power raised to another power. Right, we're going to keep the base like we always do. So the base always stays the same, and we're going to multiply the exponents. We have to apply this rule to every base in the parentheses. So here's 2 examples. Our first one just has one base in the parentheses. This is our simple case, right? So if I have x to the 3rd power raised to the 4th power, what this really means is I'm taking the stuff in parentheses and making 4 copies of it. So if I multiply x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd, we know that's our product rule. So we would add those 3's together, which would give us x to the 12th. Well, what is a faster way to get from x to the 3rd to the 4th to x to the 12th? It's by multiplying 3 times 4, right? Because that repeated addition that we did here is really multiplication. So here we go. Example number 2, multiple bases in parentheses. So here I have x to the 3rd times y. So we can really think of that as x to the 3rd times y 4 times, right? Which, if I kind of separate out all my variables, is x to the 3rd 4 times and y 4 times. So x to the 3rd to the 4th power is x to the 12th, just like before. And then y times y times y times y is y to the 4th. So really what we're doing is we're taking that x to the 3rd and the y, and we're just applying that 4th power to everything. So I think x to the 3 times 4 is 12, and y to the 1st, right, to the 4th becomes y to the 4th. So if it doesn't have an exponent, we just put that exponent on it. Okay, it says be careful with number bases. They can work just like they work just like exponents and can be multiplied out in the end. Sometimes, right? Sometimes they're too big, but sometimes we can multiply them out. So let's see an example of that. 2x to the 3rd is 2x squared to the 3rd is 2x squared times 2x squared times 2x squared. There's our 3 copies. So 2 times 2 times 2 is 2 to the 3rd. X squared times x squared times x squared is x to the 6th. But then we can also write 2 to the 3rd as 8. So our final answer would be 8x to the 6th, but this one shows our exponent rule right here. Same thing here. We're applying 8 times 2 and 8 times 4. So we get x to the 16th, y to the 32nd. Same thing here. We're applying 4 to the 3rd, right? Don't forget that base. This is going to become x to the 6th and y to the 15th. So just think about applying that power to every base inside those parentheses. All right, let's do a couple examples here. Our first example is just one base, right? So x to the 4th raised to the 5th power. We multiply and we get x to the 20th power. Our next one is 3x squared raised to the 3rd power. So that's going to look like example 3 up here. So we just have to apply that 3rd power to everything, right? So it's going to become 3 to the 3rd and x to the 6th. Remember to multiply. And 3 to the 3rd is something that we can simplify because that means 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. And our next one here, very similar to example 5, right? So we have to apply this squared to the 4, the x, and the y. So this is going to become 4 squared, x to the 6th, y to the 10th. And we can write 4 squared as 16. So this is 16 x to the 6th, y to the 10th. Our last two examples are going to involve power rule as well as our quotient rule. I can tell that immediately because we have a fraction, right? So if we have x's on both sides of that fraction bar, we're going to have to use our quotient rule. But we have to use our power rule first because, we have to do our exponents before we do division. That's part of PEMDAS. So let's apply that power rule on the top. So x squared to the second power is x to the 4th. Y to the 5th to the second power is y to the 10th. Let's undo that. 1, 0. Okay, and then on the bottom, this part's the same. Okay, so now we have to use our quotient rule. Quotient rule says subtract from the biggest exponent. Well, x to the 4th and x to the 4th are the same, so we can just cross them out. Y to the 10th over y to the 8th, right? We're going to do 10 minus 8 and cross out that one. So final answer, on the top of this fraction, we have y to the 2nd. And in the denominator, we have nothing, so we don't have to write it. Not too bad, right? Looks worse than it is. Okay, let's do this next one. This next one is going to involve power rule again. So we're going to do that power rule first. So 3 to the 3rd, don't forget that base, x to the 12th, and y to the 9th, right? I'm multiplying all of my exponents. Copy down what I have down here. And again, I'm lining up my number parts, my x parts, and my y parts. I'm going to switch colors for this next part because we're going to do our quotient rule, right? So I'm going to do 12 minus 3 and get rid of that x to the 3rd. But then for my y's, right, I have more on the bottom than the top. So I'm going to do 10 minus 9 and cross out the y's that are on the top of that fraction. All right, let's rewrite. It's always good to rewrite. So on the top, I have 3 to the 3rd, which we can multiply that out in a second. And I have x to the 9th. And then I have 9 times y on the bottom. So let's multiply out 3 to the 3rd. We have a little bit more we can do there. So 3 to the 3rd is 3 times 3 times 3, which is 27. And 9y, right? But 27 over 9, I can do that division, right? 27 divided by 9 is 3. So there's my last step. I just had to simplify those coefficients. So I get 3x to the 9th over y. And we're done. All right, these next ones, I just have a recap of the rules here. And we have this graphic organizer. So when we have a lot of stuff to do, we might want to just organize ourselves. So this is just going to remind us to do our power rule first, then our product or quotient rules. It's also going to have us check. We are done when we have one copy of each variable and only positive exponents. Now we've only had positive exponents today, but one copy of each variable. If you look at this example, we have a whole bunch of x's and y's. We only want one of each. So our power rule, we're going to do those parentheses, right? So power rule, think parentheses. So we're not going to do anything on the top of this fraction. We're just going to look at those parentheses on the bottom. So instead of y to the 4th raised to the 3rd, I'm going to write y to the 12th. All right, I'm going to change my colors, and we're going to do our product rule. So product rule I can do on the top because I have x's that are being multiplied together, right? So they're all on the same side of that fraction bar. They're not being divided. That would be quotient. So we're just going to add those exponents. So x to the 10th, right? 3 plus 7, and then y squared all over y to the 12th. Okay, the last thing we're going to do is our quotient rule. So I have a y on the top, y on the bottom, right? We're looking for those same bases. So I'm going to do 12 minus 2 and cross that guy out. So our last step is just to rewrite. So x to the 10th over y to the 10th, and we're done. There's one copy of each variable. There's only positive exponents. We are good to go. Okay, here's a real challenge one, all right? So we're gonna do all of our power rule in the first step. So there's two places where we're gonna do power rule. So this is our parentheses, right? So I'm gonna look here and here. So remember to apply that outside exponent to every base. So that's gonna become a to the third, because that one didn't have an exponent before. B to the 2 times 3 is 6. And then bring down that a to the fifth. And then on the bottom, 2 squared. And then a to the 2 times 2 is 4. And b to the sixth. Okay, again, I'm going to do my product rule next because I have a's on the top that I can combine. And I always keep my variables in alphabetical order. So a to the third times a to the fifth, right? We add those and we get a to the eighth. Then on the bottom, 2 squared I can do, I'll just write that as 4. We have a to the fourth and b to the sixth. And our last part here that we're going to do is our quotient rule. So I have a's on the top and the bottom, right? So I'm going to subtract 8 minus 4 and get rid of that one. But then for our b's, I've got b to the sixth and b to the sixth. They're the same, so we're just going to cancel them out. And that's going to give me a to the fourth over, and on the bottom I just have this 4. So we're done. There's only one copy of each variable, where our b's disappeared, but we only have one copy of a, and there's only positive exponents. We are done.